We're going to sketch some graphs with asymptotes today. Like yesterday, we did polynomials and trig functions. You sketch those using the derivatives. Kind of makes it possible to sketch some really difficult graphs pretty quickly. Today we're going to add asymptotes in that mix. So, do you remember? So mostly review still. Do you remember how to if this is an asymptote, horizontal variety, right? How would I calculate? How do you figure out where an asymptote is on a function if it has one? Okay, we're going way back. I mean, for you guys, like 2 months ago, this is like how in antiquity, so think far. Do you remember how to use limits for these?
I do not recall.
What's x approaching for horizontal asymptote? What number? It's not actually a number. So we have to analyze our limits at infinity.
Are we going to grade the free responses right now?
Yeah, thanks for the reminder. Yeah, that's a good idea. I knew there was something I was forgetting. Okay, so you have to analyze limits at infinity, positive or negative, because it can go either. Figure out where horizontal asymptotes are. Okay.
Oh, it's this.
What about vertical? Let's say that this has a vertical asymptote at x equals 0. What would the limits look like? The limit as x approaches 0 from the right would be what? Out. Right. Boom, negative infinity. And consequently, the limit as x approaches 0 from the left would be positive infinity. So you're going to see some sort of combination of that for a vertical asymptote. So horizontal, limit as x approaches infinity. Vertical, the limit equals infinity. And those can be the same, right? Okay, so handy reminder, probably on the final. No promises, but probably. So, okay, let's look at this specific. Right. Okay. Let's sketch a graph. This is a rational function, correct? Might it have horizontal and vertical asymptotes? Yeah, for sure. Okay. So you can take the derivative route first if you want, or if you recognize that as a rational function, you can calculate some limits to get asymptotes. Where do you want to start?
Which one is easier?
I don't. It doesn't matter. Okay, so vertical asymptotes. We're looking for this situation. Where might a limit be split up Do you remember how to look at that and figure it out?
You have to have like a limit or something, which is a good.
If that's horizontal.
Oh.
Okay.
So that has
What?
to be
Yeah.
What does the denominator equal?
0.
Okay, that's where our possible vertical asymptotes come, right? Oh. Gosh. So, what does x equal? 2. Right? So, to verify, two from the right and
right from the right. Oh, you do both?
you gotta see if there's a vertical. Okay, you can, I did show you how to do this without limits. Can anybody tell me why we know this is a vertical asymptote right now without limits? You look at the function. Okay, the denominator is 0, that's one factor. Can you factor this term out?
2x minus 4?
Yeah. No, you can't. You cannot factor that out. That has to be a vertical asymptote.
At the bottom, if the denominator is factored, we'll do it from the
Yeah,
top
so
too.
let's say I have this.
Oh,
Okay, you get x minus 2, so you have 2 here, right? But you can factor that out, not a vertical asymptote. It's a hole. Or like, let's be more mathy. Point discontinuity. Right. Is that, you start to remember?
Yeah.
Remember it? Remember. You all are staring at me like, I've never seen this before. You're worrying your math teacher.
That's been.
Okay, so that's the easier way, honestly. If you finish these limits up, what are you gonna get?
so you plug 2 in and negative 2?
Nope. 2 from the right and 2 from the left. So not negative 2. Negative 2 is way out. Okay, what are your solution methods for limits?
Numerical plug and chug.
Okay, we plug and chug. It doesn't work, right? Okay, do you get an indeterminate form?
Potentially, no.
No, you don't. If I plug and chug, I get 8 over 0, not indeterminate. I cannot use algebra and I can't use L'Hopital's rule.
Factor x out.
Okay? Can't factor. You can't use algebra because there's not an indeterminate form.
So then you just like
Okay.
do it.
Okay, keep going down your list. What else is there? Okay, you could do a numeric table of values, which is kind of our last resort. Does anybody have their limits card available? Is there anything on there that you could use besides numeric because it's a pain in the butt?
For example, oh, look at this. Oh.
Graphically.
You can look at it graphically. That's what we're trying to do is graphic, right? So, do that.
He is kind of.
Yeah, numeric is probably your option, which is why I would encourage you to remember this. Right. I'm pretty sure that this is what that looks like. If you do the numeric analysis, that's what you're gonna get.
Why would they be different?
Okay. You'll see when we graph it. When we get to sketching the graph, you'll see it.
So in the calculator, how do you do like 2 from the left and 2 from the right?
You remember your numeric limits.
1.9.
From the left, analyze, and from the right,
So if the bottom values are going towards like the 1.9.
so these will probably approach positive infinity, and these will probably approach negative infinity. Well, they will, actually. Is the graph, that's the graph.
Oh, I remember.
Remember now?
Now.
Yes,
It's a good thing we're like putting some detail into this, I guess. I guess I assume that you remember this.
Yeah.
That's my first mistake.
Don't assume.
It's just that
Know what this is.
I've done it like 10 years of my life. I've done this, and it's like, it is. You start to remember it, and you start to assume everybody knows it, but it's not true. Okay, horizontal asymptotes. A little easier, right?
Kind of.
The limit as x approaches
Estimating.
infinity. How do you solve infinite limits?
Oh, under the three x into x same power.
Yeah, use the highest exponent terms, and all you have to do is analyze those, right?
Oh, that's my YouTube.
What's the answer? 3/2, right? Okay, so y equals 3/2 is a horizontal asymptote.
Oh, yeah, this one is
A little easier, right? Okay, we need to do negative infinity. Is it going to give us a different answer?
No. I don't know.
That sounded like more of a question.
It was a question.
Or you do highest rating.
The same method again, right?
Yeah, when did you?
The x's cancel out, 3/2. Okay, it gives us the same answer.
Okay.
Okay, so we're good. This is our horizontal asymptote.
Did you take the highest?
No, yeah, but what's the second part?
It was a negative. That's all. Yep.
Because the x goes down.
So let's start sketching. One of these days I'm gonna get my grid back up here. Y equals 3/2. And x equals 2. Any predictions on what that graph's gonna look like? It's rational, it's positive, it's probably gonna be
Better.
here and here, right? Okay, but you can still use, I want to walk you through the derivatives just to make sure we're good on that. So you can see some of the finer points of it, but that's probably what that's going to look like. It's rational, pretty straightforward. From my
What
point
would it
of
look
view,
like if it was the other way?
it would have a negative in front of it. You mean like this? Yeah, it would be negative.
Oh,
Yeah. Pre-calculus parent functions.
Whoa.
Rational functions all look the same, and then the negative is reflected over the x-axis. So. Anybody want to volunteer the derivative, or do I need to call someone out?
for which ones?
That one.
Function.
Well,
So we're going to determine increasing and decreasing in concavity, and how it'll help us sketch it.
Maybe not this idea. So, 2x minus 4 times 3 minus
3x plus 2
times 2.
all over 2x minus 4 squared.
I'm trying to follow the 5 different versions I'm hearing, which are probably all correct. Am I right?
Yeah.
Yep.
Then you do have to simplify these algebraically, because if we're finding critical points, the top has to equal 0, right? So
So that equals 0. Should be 6x plus.
nope.
Not yet.
Okay, I figured.
Don't you only have to do the top though?
See?
Oh, boy, that's a double extended pager. We're getting somewhere now. These problems can get pretty long, by the
I
way.
can see that. It's taking it from our page.
Yeah. If you love long math problems, don't be a math major.
I'm not planning on it.
Dang it.
Or if you don't like sitting and staring at something for 3 hours and getting nothing on paper, might not be to be a math major.
Yeah, don't plan on it.
It does not. Okay, can that ever equal 0?
No.
No. Okay. So, are there any critical points?
Yeah.
Well,
Boy, he's looking at you like that.
Is the derivative undefined somewhere?
probably.
Oh, fuck me.
Come on. At?
Undefined. Oh,
Y prime is undefined at?
2.
Yeah, 2, right? The denominators. So we've already determined that. That's a transition point, right?
If we were to do the.
As yesterday would have defined for you, that would be a transition point. Okay.
Next page.
Second derivative.
Oh boy.
Why are they doing that?
Because he said so.
Well, why are
To
they
determine concavity.
Oh, it's so much fun.
Somehow I think you don't mean that.
Oh, we don't.
Wait, so you don't have to do sign analysis for that?
We will.
For the first one?
Yeah, we'll do a sign analysis around x equals 2.
Okay.
Low D high, minus high, and then the derivative of the bottom. Ooh, what rule is that?
That's a
You could say it.
It's a change.
It's not a check. It's a change rule. Thank you very much for that. Okay.
You're welcome. It's a check. I don't like talking.
So quotient rule and you have a chain rule inside it. I told you we're going to calculate lots more derivatives.
Yay.
Yay.
Ah, my line's not straight.
And this is all to determine their asymptote is?
No, this is for concavity. Second derivative is concavity.
For
First derivative determines min-max
Yeah.
increasing and decreasing behavior. The limits gave us the asymptotes.
But why are we doing this now?
Because
So we
definitely didn't want to.
sketch the graph, knowing what concavity and increasing and decreasing behavior. Like yesterday, use the first and second derivative to determine what more things are wrong. Okay.
Like everything.
Okay, 0. Is that 64 times 2 is 128x,
Oh, goodness.
256.
That's perfect.
Is that right?
Yeah.
We'll go with that.
I hope it is, because it might mess us up.
Yeah, that's good.
That is not pleasant
Why is it so unfortunate?
Why
because
is
Oh.
below squared?
squared times 2.
Okay, second derivative equals 0. Where?
2.
X equals 2, right?
Yeah.
And it's also undefined at x equals 2. So x equals 2 seems to be a pretty big location for us on this one, right?
Yes, yes it does.
Alright. So,
So there's a critical point at x equals 2? And there's something at x equals 2?
there's lots
The
of things.
function.
Why?
Yeah, the function's is not continuous. Right, so the function's not continuous at 2. Therefore, you know that the derivatives are going to be undefined. They're not going to exist. Right? Which is because the denominator is going to have 3 to 0.
How does that work on the graph?
Well, it's either got a vertical asymptote or a point discontinuity. It's not continuous, or jump discontinuity. Or a point or a
Thought we already
cos.
established that there isn't one.
There is, yeah, we already know that.
So this is just a number?
This is
is
going to
just the
tell us what the graph is shaped like.
We already know.
Yeah, I know that, but I'm taking you through the exercise so you get, see, here are the finer points, like, can this derivative equal 0? No, but it's undefined at 2. Like, it's totally like reviewing for your final exam right now. Are trying to reject that, I don't know why. Okay, now you do your sign analysis.
What?
Can somebody just park? Or is there a baby elk in the room?
Just kidding.
Okay, and our only transition point is 2, right?
Yeah.
So it makes it easier. So what is f prime at 1? And I, again, use the simplified version. It's negative,
Negative.
right?
Yes.
And then f prime at 3.
I thought we only cared about the numerator. We didn't do any sign analysis.
No, no,
No, you do the entire
that's
function.
the whole thing. Also negative. So we know that function is decreasing,
It's not, is it negative?
It is negative.
but this is
It has a negative
always going to
sign.
spit a negative out because you have a squared term which is always positive.
And then a
And a
negative.
negative.
on top.
So that function is monotonic, it's always decreasing.
Oh, joy.
And then do the same thing with your second derivative. Oh, that should be 1. That's fantastic, well done.
Go.
The second derivative at 1 is
Positive. No, that's negative.
negativo. Concave down, right?
Yep.
And the second derivative at 3,
No, wait.
Positive.
concave.
Oh,
Oh,
the second derivative is the concave.
so we have decreasing and concave down. That's what that looks like, right?
Yes.
Decreasing, concave down, and on
Yeah.
this side of the world, we have decreasing and concave up.
Well, I thought the horizontal asymptote was at 3/2.
It is.
So where does the 2 fit into the graph?
The
X
two
equals
are
2 or Y
vertical.
equals 2?
X
X equals 2.
That's
Or
the vertical.
asymptote. We have an infinite discontinuity, which pushes us into a derivative and beyond that's undefined.
Oh.
See how much information is here for this one problem?
So y equals 3 over 2.
Y equals 3 over 2 is our horizontal asymptote.
So where did we get, when we were doing the limit,
Limits at infinity.
where did we get 2 in doing that?
We looked at where the denominator
That's just
was equal to 0,
No, the 2. Oh, okay.
and then made sure that couldn't be factored out. Vertical asymptote.
And I did the
Woohoo.
numerator too.
The what? The numerator doesn't have a bearing on vertical asymptotes,
So you just
unless
found
you can factor something
just found
out.
both asymptotes.
Okay, so yes, long problem.
Yeah, it's impressive.
And to be honest, the derivative, second derivative analysis is unnecessary if you remember your pre-calculus beyond limits. Okay, so I will not require this from you because it's unnecessary, right? But it's a good exercise to go through and see how much information you can get from derivative, second derivative. Okay. And I trust that you can do that faster than what we just did in 15 minutes.
I hope so.
Maybe not.
Because that's a lot of problem. There is another one. It's the same type of problem,
No thanks.
except it has two vertical asymptotes.
Did that one
Would
not?
you like to see it? Just like,
Show the graph.
we could just draw, at least talk about the limits maybe?
Yeah.
Would that help?
Yes.
Okay. Okay. Let's talk.
That would be a good help.
Okay. Again, it's rational, so you're automatically thinking I probably have some asymptotes, right? Where are they?
Actually, which one?
Okay, so x equals 1 is what? That's where this is undefined, so you have a,
Please release the state theater students. Go break a leg.
nobody's leaving?
No, it's too expensive to go.
No kidding, you have to pay your way?
Oh, yeah.
Dang, I didn't know that.
That's expensive.
Highly broke.
It's like $150 to $200 depending on what you're doing.
Yikes. Okay, vertical asymptotes. Denominator equals 0. Okay, so what x values are we looking at?
Hunter, Kendra,
Okay.
Mason, Kenzie, Jake.
So you don't have a teacher then?
That's why she's gone the next 2 days. That was mine.
Okay, we know those are vertical because we can't factor anything out of here, right?
Yeah.
Okay, horizontal
So they're
asymptotes.
vertical and you can't factor anything out?
Yeah, look at the original function. Can you factor the denominator out with the numerator? No.
Sir.
Okay, good. Horizontals. Limits at infinity. Bottom's really big, going towards 0. Okay, and the same with
Wait.
the negative.
The
I'll wait for
powers
nobody.
of the bottom is really big.
This may not be strong.
1 over infinity is really close to 0, correct?
Oh, yeah.
So the bigger the number here in the denominator, the closer we're getting to 0. 1 over, okay, let's say, what's 1 over 10? 0.1, right? What's 1 over 100? 0.01. 1 over 1,000, 0.001. So you're getting closer and closer to 0. You just never will touch it. Okay? So we have a horizontal asymptote.
I went on the hunch a lot when you said that. Yeah, they would think.
Have you ever graphed
Colors.
with two
No kidding.
vertical asymptotes? Would this be a situation where it would be handy to
Cute sizes of.
use the derivatives?
Probably.
Possibly. It's rational, so you know the shapes already. You just need to figure out whether this one is here or here. And that will set the rest up, because they always alternate, the rational functions. And so it's, okay, let's just analyze what's f at 0. Yeah, -1, right? So we are located here.
Yep.
Is that open and up or down? Yeah, it's gotta be down. You can't cross, you're not gonna go across that. So we're looking at this. And consequently, I think the graph is gonna look like a rational. So are we
That's how I feel.
here? Which one of these is it gonna sit in? We're gonna have a graph here or here? Here, there, here. There, here. The bottom?
I think so.
This is already in the bottom.
Oh, but it's
Be
in
on
top.
top.
It needs to be on the top.
Why is it like there? And not in
It's
the-
rational, they always alternate.
But then when
And
the
Oh.
plug 2 into
And
that.
just like the previous one. See how they're different? The vertical asymptote, they alternate.
So why wouldn't it be in the slim part of the up top?
Because it fills in.
Because we analyzed f at 0. If x is 0, the function is -1. So you have to know that it opens down.
Oh, I get it now.
It gives us everything else we need.
Uh-oh.
So you just avoided a bunch of derivatives work, right?
Yes, we did.
Okay. Again, only if necessary. Would the derivative
What is
be positive or negative in this area?
Positive.
negative?
Positive.
I don't know.
Maybe you should like fight it out.
Positive.
It's
Why is it positive kilos?
Oh, positive.
Yeah, we are increasing.
Good job, Kim.
And the second derivative is what, Brandon? Positive because we're concave up. So if you did the analysis, you would see that.
So, oh, this one.
Okay, this one has to be split actually. Derivative there is positive, second derivative is negative, right?
Why do you have it split?
Because it goes up and down.
The graph here is increasing and then decreasing.
Oh, okay.
So the derivative switches sign. Yeah, so, and then here you have f prime is negative, f double prime is still negative, right? What about the other one? F prime negative, f double prime
Positive.
positive. Good, okay.
So is the double prime, is it
It's
just opening down
concave.
or opening up?
Yeah.
That's how you get your positive and negative things.
Is this x equals -1 a point of inflection? Remember, a point of inflection is where we transfer concavity, changes sign. So the second derivative is positive 2.
Negative.
If that's a point of inflection, okay, what happens here? -2, positive, yeah. Okay, so we have 2 points of inflection, right?
Yeah.
A negative 1 and 1.
What about this point? What would we call it?
Yeah, 41 by F.
The derivative goes from positive to negative.
Oh, what is it?
That is a,
Critical point.
okay, the critical point, and more specifically, a local
Max.
maximum. So see how much, all that information is there, it can be justified with the derivative second derivative, right?
Yep.
All right. Any questions before I stop? Will you please stop? Yes. Okay.